My definition of big data is the data that is below the level of transactions to the interactions. And the characteristics of this data is that it's going to come in different formats. It's going to have structural changes compared to what traditionally comes out of a core banking system, an ERP system, and so on. And the volume is going to be orders of magnitude greater. Big data allows you to see the experience of the customer, right? Traditional data, when you collect the transactions, let's say, for example, if you're a telecommunications company, you might have all the call detail records, which are input to a billing system, and then you know the value of the customer, how many calls did they make, and how many pesos was each call worth. But it doesn't really tell you the experience of the customer. You don't know if they had a high quality voice service or data service. You need to get below the level of the transaction detail to the interaction. And that means collecting data from the network at a much lower level of detail. That big data will allow you to see the experience of the customer. And then after you've delivered the service, you can collect data from, for example, social media when they're tweeting about the experience or they're blogging about the experience. You can get from that sources a different way of looking at voice of customer, sentiment scoring to understand, again, the customer experience. And then ultimately measuring that through sensor data in a number of industries will become increasingly important. Three phases of big data deployment, and right now we're really in the second phase. The first phase was going below the level of the transactions, which were people buying stuff on the internet, to the interactions, which was getting all the clicks and all the searches that led up to the buying. And the first wave of big data analytics was mainly focused on the .com players, people like eBay and Overstock.com and Netflix and those kind of guys. And then in the second wave, which is really where we are now, we started looking at interactions through social media, capturing the Twitter feeds, the Facebook microblogs, voice, text, all kinds of sources of data, which really were not previously used very effectively. Now with the big data technology, we can exploit that, especially for voice of customer types of applications. And then the next phase of big data, which some companies have entered, but it's really not, where the mainstream is now, but I think it's going to create, orders of magnitude more data and more value, which is sensor data. So the third wave of big data analytics is going to focus on sensor data. Data that allows you to understand, for example, how a car is being driven. So we can increase the safety of the vehicle. We can make recommendations for improving driving habits of the driver. We can do condition-based maintenance so we understand when to do maintenance on the car. Those same kind of principles can be applied in healthcare. Right? So we can capture data from the body using wearable jewelry like Fitbits and Apple Watch and so on. That data can be analyzed to tell you, how to improve your sleeping habits, your exercise habits, your eating habits, when you should go see the doctor, these kinds of things. So the applications of sensor data across, many different industries is huge. So we often refer to this concept as the Internet of Everything. Everything will be connected, everything will be measured, and sensor technology is at the center of that. We want to take the data from the sensors and analyze that to understand how to become more efficient and provide higher quality of life. Teradata's goal is to enable companies to exploit big data. We have something which we refer to as the unified data architecture, which you use a combination of commercial software and open source software to deliver an analytic ecosystem in terms of the hardware and the software, as well as the delivery capability to unlock the value in big data. So Teradata manufactures and sells an appliance that focuses on how to deliver data as a product. It's a relational database technology integrated with standard high-volume server technology from Intel and infrastructure for connecting all the pieces together. We have a discovery platform which is based on software that was developed at Stanford University. We acquire that software and the patents and have a discovery platform called Astrodata. And then we integrate that with open source technology. We have an appliance where we integrate Hadoop software together with a scalable, massively parallel processing architecture to create the unified data architecture.